Hello, this is John Vincent back with you here. And again, I'm based out of the Milwaukee, Wisconsin area if you haven't seen any of my sessions so far. NX user for about 18 years, handling both CAD and CAM topics. So in this next session, we're going to be covering on-machine probing. And now NX out of the box can support some on-machine probing, given you have the appropriate licensing. However, there is a new set of tools, which really consists of a download that's available on PostHub. And this was created by Thomas Jenisch in Germany, and with some support of some other resellers and customers in play overseas. But what's been provided is some template parts and template operations that were built on the generic motion platform to go ahead and drive these tool paths or these probing paths. In addition, we're given with the download from PostHub a few tools. I don't know, maybe half a dozen or 8 probing assemblies, and a post configurator post layer that we can import into an existing post configurator post that we're already using. So we'll take a look at what's included in the download, how to install it, and then how to actually utilize these tools. So, going on and looking at the setup involved with the on-machine probing. Also, first things first, we have to download the kit essentially from PostHub. Now we can access PostHub via the URL here, or if you're in NX 1899 and later, directly from the post-processor dialog, you can access PostHub. By either method you choose, you'll have to log in with your WebKey account information to gain access. And now the kit that we are going to be downloading was developed for FANUC-based controllers. So, that being said, if you have FANUC-based control, or if you're okay with doing a little post-customization, you can certainly utilize these operations that have been created for us. Alright, so let's dive in here. I'm simply going to start by going to PostHub's website, and we'll navigate there, log in, and we'll get to our the downloads here section, and we can see that once we get in here, we can enter probing for our search criteria, and we'll be able to find our probing layer for swoosh-based controllers. And you can click on the information window, and we'll see that we have all the typical information that's included as far as who created this kit, what's included, maybe some sample code, things like that, with the installation. But directly through this URL, we can go ahead and download this kit. So once we've done that, we can look. We'll have to go ahead and unzip that, the contents of this. There's very good documentation included with the download, so that'll walk you step by step. But we'll take a look at the overview of what's involved here to go in and install this. So we're going to do a few things to start. We're going to copy the template parts that are included, bring them into our standard NX installation, as well as some images. And the images are just used they're embedded in some of the operations describing what various values are inside of a probing operation. Okay, so here on the top side of my screen, I have the location and the files that I downloaded from PostHub. And on the lower portion of my screen, I have my NX 1980 installation location, and we'll be working within the mock directory. So here I've gone and found under the template folder of the download, there's 2 part files, and those are going to come into our template part folder, and these happen to be metric files. So I'll go ahead and copy these operations into resource template part metric directory. Once I have those part files copied, we also want to bring over all these images that we talked about. Again, these will be used as flyout images from the create new operation dialog, as well as embedded internal to the operations themselves, kind of as a helpful hint of what the various parameters are. So again, if we're in the mock resource template part folder, there's an image directory, and we can go ahead and copy all these images inside of that folder for use while we're inside of NX. So once we have those standard operation templates installed on our system, we're going to bring in some probes. So Thomas and the guys there, they've built some Renishaw tool assemblies here, just various types of probes with different diameter stylus and length stylus for various scenarios. And typically most machine tools just have one probe, but you certainly can have multiple probes in a machine if you have the requirements that make sense to do so. So we'll look at bringing this data on over into our own installation. So again, inside of the downloaded package from PostHub, we'll go to the Tools directory. And inside of here, we'll see two different things. We'll have a graphics folder, and inside of that, we'll have a folder for each tool assembly. We're going to go ahead and copy all of these folders into the Tools graphics directory in our standard installation. So again, this is going to be in Resource, Library, Tools, and then there's a graphics folder, and we can just copy and paste all of the folders inside of this same location. And then in addition to this, we have a database file, a .dat file, and this is going to include the information behind these tools. So this is what NX we need to import into our own tooling database. Here you can see the what this data looks like, the various information for these tools. But if we go go into NX, and a new tool was introduced a few versions ago now, it's been around a little bit, to convert tool library databases. And we can actually use that to kind of merge these two files. So under Menu, Tools, Convert Tool Library, while you're in the manufacturing application, we can go ahead and navigate to where we installed or downloaded this kit, this layer kit from PostHub, and import the probe tool database.dat file. Now that'll just append all the data into our active tool database for us. So now, once we load that and I search for my under solid tool probe, instead of the one metric probe that was included out of the box, I now have 9 matches here, including all the Renishaw assemblies that were created for us. And after that, we're pretty much ready from the NX standpoint to use these operations and start programming them. But from the post standpoint, we need to embed the included layer in our standard post. So if you're using Post Configurator, this is a really easy change to do here, and a modification. If you're not using Post Configurator yet, and you still have a Post Builder post, or maybe you're using a third-party post, you can still use the operations that have been created for us here, all those operation templates. However, you'll have to handle the post creation or enhancements in Post Builder or with whatever third-party software you're using. So if you're, for those that are not that familiar with Post Configurator yet, there's a concept of layers, and this kind of takes importing, exporting custom commands from Post Builder to the next level, where we can include not only TCL and various procedures, but we can include definition files and other data with this. So right now we're going to go ahead and select the layer that was included in the download, and we'll navigate to there. And in my case, I'm just going to go ahead and activate this layer in the dialog. So once I press OK, you'll see my interface is going to change quickly here. You can see at the bottom, we now have the Siemens DI probing settings. So all this interface was added via the TCL code that was included with this layer. So what we have here is the ability to change some options. We have some different formats, this probing controller option for Renishaw machining centers, Renishaw for Mazak, or just a generic output. So you can go and make that selection. And so on and so forth down the list here. Do we want to display our probing comments? Do we want to see sequence numbers? Do we want to support swivel plane cycles inside of the particular post that we're using? So all this can be used regardless of what kinematic configuration of machine you're using. Makes it very nice. And then we have some further cycle settings. Maybe your Renishaw cycles are numbered differently than kind of the typical scenario. You can go ahead and change those subprogram commands here, as well as decide, do I need to activate my probe? Do I need to turn my probe on and off? Certain machine tools require that either when you tool change and load your probe, automatically the probe is turned on. Other machines require you to turn it on via a command. So you can make those decisions all through these pull-down menus here inside of Post Configurator with this layer that's included with the download. After that, we can look at this customization entry points. Maybe we need to modify the code of how it's built here. So the great thing, we can do a lot of customization, enter our own procedures here. We can still fully utilize buffers in all of these events to really understand and interpret what's going on, and maybe make some modification based on our own particular needs. But once we get that, we can then look into the CSE simulation settings. So kind of two approaches on how you can simulate probing cycles. One, you can go ahead and output the code that's been given to us here. This is really emulating the motions and looking at the values that are going to be output, and it's creating subprograms for us that the CSE will use, the Common Simulation Engine will use while we're simulating our tools, or our tool paths. The other option is to go ahead and, if you have access to the machine tool and the probing subprograms are available to you, you can load them into your machine tool configuration and run the actual code from the machine tool itself. Two different options, and that's going to get into a little bit more customization of simulation topics than we're going to be able to get into here today. And of course, the last tab here is just the versioning information. So as they make updates to this kit, it'll be updated on PostHub, and we can update things as enhancements are made. It's worth noting that this whole layer, and along with the templates and things, these are not official Siemens tools. They're available for download on PostHub, kind of at the user's discretion. So if you call and have an issue with these, make sure that you're getting a reseller like Swoosh involved, or you have the contact with the appropriate people at Siemens. If you go directly to the GTAC Siemens Support Center, they aren't going to be able to support you with these topics. Just worth noting there. Okay, so now we want to look at what does it really take to go ahead and program utilizing these new operations. So, to look at that, what we want to do is take a look inside of NX, see exactly how we can go ahead and program these things, how we can simulate cycles, and what some of the different options are within the probing operations themselves. Now, when I talk to customers about probing, I often get a lot of questions or people approach me saying, I want to be able to probe. And I say, oh, that's great. What are you trying to achieve? And I'll get some blank stares and say, I want to be able to probe. I want to do everything. Well, it's not necessarily that easy. There's just more that goes into it. It's not that it's difficult. So typically I look at it from two aspects. One, you want to aid in setting up of your workpiece. Either we want to probe rough stock to pick up a work offset, or maybe pick up a work offset off of a previously machined feature, or we need to orient our rotary axes on our machine tool based on previously machined features. So there's a lot of different scenarios there. But that's kind of the first aspect. The second aspect is measuring features that have been cut on our machine during our operation. So really in process features. And what you'll get out from that is either some size. You'll measure a bore or boss or a pocket or a depth or something like that, and you'll get that value. What you do with that value is a completely different topic. I mean, we can write it to a file, to a text file. Depending on your control, you can display it on your screen for the operator to see. We could actually get into full customization where we're measuring based on some tolerance, and then what do we want to do? If we've blown size on a part and it's oversized, you might want to alarm the machine out and make sure somebody manually intervenes and decides what to do with that part. Or if it's undersized, there's material left. Maybe we want to adjust our tool compensation diameter and go ahead and rerun that operation. So lots of things you can do there. So here we're looking at just basically a demo part that has a bunch of different operations created from various things like single point probing in XYZ, hole probing, boss probing, so on and so forth between the different options here. So let me back this up and start that over again. So once we start looking in here, we just wanted to show what the dialogues will look like. In this case, we have the single point Z probing operation open. We get a nice image here describing what the various values are that we have to specify. In this case, we're just picking a location, so we're actually specifying a point on our part. And then we'll go through and have to specify a probe security height and a clearance plane height. Now, all this information is going to be used to actually create the probing path. And as we go down through the dialog here, we'll be able to do things like update our data. Do we actually want to write the results to a work offset? So we can just toggle that on here with the radio button and select which datum do we actually want to update. Or do we want to use this measure cycle and store the data? In this case, we're storing pound 138. That's the result of this measurement cycle to our variable pound 901. And then maybe I'm using pound 901 in a subprogram, or I'm writing that to some file, something of my choosing as an end user. And we can fully utilize notes just like you would from any other operation. Might be a good opportunity to enter in what the measurement is of the feature, as well as tolerance. And so that information is going to be output right in the code. So the machine operator has that, and they don't have to go and reference another document like an actual two-dimensional drawing to gain that information. Tool and geometry, all standard NX stuff. Nothing special here. It's going to have all the probes that you have available in your setup. Of course, you could browse to your tool library and select the right one. You can change your geometry groups, program groups, all of those standard NX functions there. And then when we get into the options tab, we have our speeds and feeds. Not really important for this operation because most of it's handled based on some other logic here inside of this sub-operation manager. This is really the heart behind these operation templates that have been created for us. So if you haven't used generic motion, pretty cool stuff you can do here as far as creating different conditional moves, making tool paths actually based upon variables or other pieces of information that you want to customize and access. So anybody can go ahead and build an operation like this from scratch if they so choose, but all that hard work's been done for us already. All right, so now we want to just review, well, what can we do? How does it work? What does it look like when we're hands-on here? So let's go ahead and do a little live demonstration and see what this looks like. All right, so in this case, let me go ahead and open up my part file. And in this part file, I have a post and a machine kit. This happens to be a Doosan machine. And I've integrated all the information that was downloaded from PostHub inside of this machine kit. So you can see this is the sample part Siemens provided, and they provide this with the PostHub dialog. I've just gone ahead and implemented it in my post, and I've loaded my machine setup in this part file. So before I do anything else, let's just go ahead and simulate this. So in here we're probing single positions, X, Z, or Z, X, Y, doing some various hole probing, boss probing, ribs, pockets, webs, slots, C-axis positioning, some rotary alignments. So of course, as we're going to go through here, we're going to spit out all the commands for the various Renishaw subprograms. So this G65P9810, that's calling the cycle for a protected move. So what that means is the tool probe is not going to be expecting any measurements to be taken or any hits to occur on that stylus, but it's going to be active. It's going to be ready to go ahead and receive those measurements. In this case, it would the machine would stop motion as soon as it sees any sort of a signal there. P9811, that's the cycle for a single probe measurement. So you'll see, even though we have different operations for measuring in X or Z or Y, it's really the same command. It's the same subprogram running, but we have Z motion or X motion or Y motion. Whatever's appropriate for the given scenario. And let's go ahead and start the simulation here. And we can see that we're going to go through, measure our part. Here we're measuring various bore cycles, features, depending on what we're doing. Over here in the code, we can see that, yeah, we're saving some variables off to other variables as we're going through. So a lot of different features that we can do. Let's just zoom out here and kind of finish playing this through. You'll see we'll get some different cycles going there, some C-axis alignments. So that's interesting stuff, but let's take a little deeper dive in here. So for instance, this single point Z probing. If we go ahead and edit this operation, again, we'll see kind of the standard values in here. Our probe security height. Again, we can reference our image to see that's essentially the probing motion that we're going to be setting. We're going to be starting that motion from 5 millimeters away from wherever I'm defining my probe point. Same thing like with my clearance plane. I can adjust all that in these parameters here. And so let's go ahead and just post out this one operation now, just to see the result. And if I come down and we look at our code, we can see that, yeah, this is just a simple single point measurement, and the probing cycle is essentially going to do nothing other than it's measuring based on what my G54 Z position is, and it's going to give me some variance to that taught position. But we're not really doing anything. If I am saying this is a known surface, this face is finished, and I want to set my Z to that height, I can simply come into the operation, turn on this button to update datum, and if I post out the code again, we'll see one small change in the result. This time we have the same cycle, but now we have an S word in here, S1. And that's telling the cycle to go ahead and write whatever my Z position is, write that to my work offset for G54. And if I would change it in the pull down G54, G55, G56, it would correspond to S1, S2, S3, so on and so forth. Same thing with some alignment options here. Let's look at some of these. In this case, we're going to go ahead and establish a point. And we can see what do we want to measure here, or what's in this case the width. We're going to measure 2 points. So we have an additional parameter here, the measure width. That's going to control this distance from the point we selected, and we can give it and tell the operation what's the initial C-axis position. So if we were to measure this surface and it was off by a small value, let's say 0.2 of a degree. Okay, it knows that it was at C0, and it's going to go ahead and create that 0.2 of a degree offset. Maybe we're at a different angle, and we need to tell the operation, yeah, we're at 90 degrees, so now, apply 90 degrees plus whatever our error is here to our standard position, if we're going to go ahead and update that datum. There's different information in different scenarios. You have to understand that some of the probing routines and so on and so forth when you're doing this. But very similarly, let's go ahead and post the code, and we'll see the difference in the cycle here. So now we're using the 9818 cycle, and you can see all of our positions that we're using. And of course, prior to this, again, FANUC-based control, we're positioning our rotary axes here with G68.2. So we're positioning, in this case, we're just moving our machine 90 degrees based on these Euler angles. So really great enhancements here. If you do a lot of machine probing, you're likely doing a lot of programming by hand or using a lot of UDEs, insert statements, things like that. So here's a great way to go ahead and do some of that through a standard NX graphic interface. And I hope you found this beneficial. And if you have any questions about this package and you want to discuss it further, please feel free to let me know. Thank you.